Everything in the universe is made from atoms. For example, a beach is made from 100 billion grains of sand, and each one of those grains of sand is made from atoms. In a single grain of sand, there are 29.8 quadrillion atoms. In 1803, John Dalton developed the first atomic model. This model suggested that atoms were tiny solid spheres that could not be broken down any further. He goes on to suggest that different spheres make up different elements, and that these different spheres come together to make compounds. Nearly 100 years later, J.J. Thomson developed the plum pudding model. He suggested that atoms were balls of positive charge with negative electrons embedded within it, a bit like a plum pudding. More importantly, Thomson noticed that atoms could be broken down even further. A few years later, a man called Rutherford fired alpha particles at a thin piece of gold foil. He expected all the particles to pass straight through, and most of them did. But to his surprise, some alpha particles were deflected, and a few of them were even reflected back towards him. But what did Rutherford conclude from this? Well, since most particles pass straight through, he worked out that atoms were made of mostly empty space. With some particles being deflected at large angles, he realised that there must be a concentration of positive charge and mass in a nucleus. And finally, since a few particles were completely reflected back, this suggests that the positive charge and mass are in a tiny volume. So, in Rutherford's atomic model, we have a small positively charged nucleus that is surrounded by mostly empty space, with a thin layer of electrons surrounding the nucleus. Just a few years later, Niels Bohr discovered that the electrons orbit the nucleus at different energy levels and distances, a bit like the planets in our solar system orbit the Sun at different distances. This discovery explained why different elements burn with different colours. For example, lithium burns with an orange-red flame, copper burns with a green flame, and potassium burns with a lilac flame. Thanks for watching. If you enjoyed this video, please like and subscribe.